Welcome to video 2 for the summer homework packet answer key. In this video I'll cover problems 3, 4, and 5. Alright, in problem 3 we're going to be dealing with exponential and logarithm problems. 3a gives us 5 raised to the x plus 1 is equal to 25. In this exponential problem, I noticed that both the number on the left and the number on the right are both base 5 numbers. So what I'll do is first I will write them as base 5. The left does not change, and the right becomes 5 squared. Now that I have a common base, all that I need to do is set the exponents equal to each other. So I say x plus 1 is equal to 2. For the curious, one of the reasons we can do that is we take log base 5 of both sides. Log base 5 of 5 squared. And what winds up happening is we can bring the exponents down in front and the log cancels out. But I think it's easier just to say that because the base is the same, we can say the exponent is the same. And subtract 1 across, and we get x equals 1. That is our final answer. Moving on to 3b, we have a problem which is very similar. 1/3 equals 3 to the 2x plus 2. And again, what we have is a case where our bases can both be written as a common base. The left-hand side is 3 to the negative 1, and the right-hand side is already in base 3, so we don't need to do anything. And now we can say that the exponents are equal to each other. Negative 1 is equal to 2x plus 2, and solve for x. So subtract 2, we get negative 3 equals 2x, and then divide by 2. Negative 3 halves is equal to x. Moving on to 3c, we are dealing with logarithms, and very simply this is just applying the conversion between a logarithm and an exponential statement, where we can say that this can convert into an exponential statement by reading as b to the x is equal to a. So that's the conversion between logarithms and exponentials. And for us, we have log base 2 of x equals 3. So we can do 2 to the third is equal to x. 2 to the third is equal to x, or 8 equals x. That's just a straightforward conversion between logarithms and exponentials. Alright, for 3D, we got a little bit more work cut out for us. The problem starts off log base 3 of x squared, and this is equal to 2 log base 3 of 4 minus 4 log base 3 of 5. And the great thing is all three of these are a common base, so that's going to allow us to combine and simplify our problem. And the first thing I'm going to do is I'm going to apply the property that says if I have a number times a log of an argument, I can convert that to log of the argument raised to that power. So basically the number in front moves up. And I'm going to apply that to this piece and this piece. So my equation now reads log base 3 of x squared equals log base 3 of 4 squared minus log base 3 of 5 to the 4th. I can very quickly simplify this down to log base 3 of x squared equals log base 3 of 16 minus log base 3 of 625. Now the log property that I want to do to combine these two is, what I can do is, let's shrink this down. I can take the log property log A minus log B equals log A over B. And in doing this, to the right-hand side of the equation, what I will get is log base 3 of 16 over 625. And we'll leave the left-hand side alone. Alright, so now what we have is two logs, one on each side of the equation, and the base is the same. So effectively I can cancel them out. One could say I exponentiate both sides, make them the exponents, and the log and the 3 cancels out, and we get x squared equals 16 over 625. And if I square root both sides, I get x is equal to 4 over 25. And keep in mind, since I'm square rooting the x, this could be plus or minus 4 over 25. I would need to check to see if either of them are outside the domain. So I check positive 4/25, and I'm allowed to take the log of a positive number. And then I check negative 4/25, and if it weren't for this squared, I would be taking the log of a negative number. But because I'm squaring that negative number, it cleans out, and both answers are acceptable. Infinite power! Alright, moving on to problem number 4. 4a and b are both logarithms, and these ones look as though we are condensing the logarithms, or simplifying them. So log base 2 of 5 plus log base 2 of x squared minus 1 minus log base 2 of x minus 1. And there's no numbers in front. If there were, we would move them up front first. But since there's no numbers in front, what we can do is we can combine them. Two logarithms that are being added together can be combined using the log property log A plus log B is log AB. So what we have here is log base 2 of 5 times x squared minus 1. So we've combined the first two logs. And then the second property that we can apply says that if we have two logs that are being subtracted, then we can write it as log of one over the other. And keep in mind, the base has to be the same. So we can combine these two logarithms to be log base 2 of 5 x squared minus 1 over x minus 1. And the final thing is we take a look at the fraction inside and ask ourselves if it can be reduced at all. And in this case, we do have a reduction. We can write this as log base 2 of 5 times x plus 1. And for the curious, what we did is we factored x minus 1 out of the top and bottom. But we have to be careful here. By doing that, we actually have a restricted domain, and this is kind of going above and beyond in the understanding, but we should be able to say that the answer is this with x not equal to 1. Because if x did equal 1, then we would not be able to take the log of that. The reason being, there's a denominator here that if we plugged 1 into the denominator, we'd be dividing by 0. So we're not allowed to do that. And if we look back at the original equation, you can't take the log of 0 anyways, so that was outside the domain to begin with. Incidentally, -1 is also outside of the domain, but this problem here, once it's all simplified, we can see that -1 is still outside the domain. Alright, moving on to 4b. What we have is 2 log base 4 of 9 minus log base 2 of 3. With this problem, there's a couple different approaches that we could take. One of them would be to try to write this log as a base 2 logarithm, or write this one as a base 4 logarithm so that we could combine them. We could also try the change of base formula and see what happens if we do that. What I'm going to do is I'm going to take this logarithm and write it in base 2. So this process is a little bit convoluted, but what we have here is a logarithm. Let's say if we said that this was what we had and it was equal to some number. What I could say is 4 to the x is equal to 9, or 2 squared to the x is equal to 9, because 4 is 2 squared. If I do that, what I can then do is convert back to a logarithm and say that what we have is log base 2 of 9 is equal to 2x, or I can put the 1/2 out front, i.e. divide the 2 across. So now what I've done is I've taken this and converted it into a base 2. And keep in mind there was always the 2 floating around out in front that we need to account for. So if I do that, then my logarithm actually can be rewritten as 2 times 1/2 log base 2 of 9 minus log base 2 of 3. And the 2 times 1/2 cancels out, and I'm left with 2 logs that have the same base, and because they are being subtracted, I can apply the property that we saw in the last problem of dividing one argument by the other and arrive at my final answer. This certainly isn't the only way to do the problem. This is just one approach that jumped to mind the quickest. Alright, with 4c we're still doing a little bit more with logarithms. However, in this one we have an exponential statement. 3 raised to the 2 log base 3 of 5. And what I'm going to do is first I'm going to simplify the exponent. So what I have is I can move the 2 up front, from up front to above the 5. And now what I see is that my base and my logarithm are of the same value. They're both 3's. And when that happens, they cancel out, and you're left with the answer of 5 squared, or very simply, 25. Have you ever wondered what caffeine looks like under an electron microscope? Alright, problem 5 is the last of the logarithm problems, and what we have here is log base 10 of 10 to the 1/2. And this is actually a pretty simple problem. The 1/2, just like logarithm rules have shown us, can move down in front, and we have 1/2 times log base 10 of 10. Another logarithm rule that we may remember is if our base is the same as the argument, it is equal to 1. So in this instance here, our base is the same as the argument, so that is equal to 1. And we get 1/2 times 1, which equals 1/2. 5b is going to be pretty similar. What we have is log base 10 of 1 over 10 to the x. And with a little bit of manipulation to our argument, we could write this as 10 to the negative x. Remember, by moving our denominator up to the numerator, it changes the exponent, the sign of the exponent. And again, then what we can do is we can bring our power down in front, and we get negative x times log base 10 of 10, which we know to be negative x times 1, or negative x. Okay, finally with 5c, what we have is 2 log base 10 of the square root of x plus 3 log base 10 of x to the 1/3. I'm going to rewrite that square root of x as x to the 1/2. And I'm going to take this 3 and move it up front, from front to the exponent there, so what we have is log of x to the 1/3 to the 3rd. Notice I've dropped writing the base in there, and you're allowed to do that because it's base 10, and if you don't have a base written in the location, then it's assumed to be a common logarithm, which is base 10. Now the next thing I'll do is I'll take the 2 and move it up front as well. Move it from the front up to an exponent, and I will distribute the 3 in, x to the 3/3. So what I have is log of x plus log of x, because the 2 times 1/2 it becomes a 1, and the 3/3 becomes a 1. And log x plus log x, or something plus itself, is 2 of those, or if you wanted to write it as log x squared, you could do that as well. Ask good questions, conquer the world.